So as you heard, my current role is CEO of eazyBI, but I still do love coding, and I like to do it from time to time. And especially performance optimizations are one of my favorite topics, and I'm happy today to share some things that we have done over more than 6 years in this area. But first, as we will talk about HTTP requests, then below HTTP there is a TCP/IP stack. Let me start with that. And at first I wanted to tell you a UDP joke, but I'm not sure you will get it. So did you get it? Well, I don't care. So therefore I thought that maybe better I'll tell you a TCP joke. Do you want to hear a TCP joke? Yes, you want to hear a TCP joke. Are you ready to hear a TCP joke? OK, you're ready. Here is the TCP joke. Did you receive the TCP joke? Yes? OK, excellent. You have received the TCP joke. Goodbye. OK, now that we have covered the underlying TCP/IP stack, let's move to the real content of the talk. I will talk about, at first, comparing server apps versus cloud apps in terms of API usage, and why you should learn and know your technology stack, how it performs these API talks, how you should do instrumentation and profiling of these calls to be able to optimize them. And then I'll share different strategies how to improve REST API calls, also including error handling. And at the end, I'll tell about some alternatives that you might consider. So at first, if we look at server apps, traditional P2 apps that many of you have developed, we have quite often a single server, single database running Jira or Confluence server. And in the same JVM process, your P2 app is running and using Java APIs, which typically provide all the information that you need. And sometimes if it doesn't, it's possible that you can make directly SQL calls to get the data. And then if you compare it to cloud apps, to Connect apps, then how typically it is presented, that there is still some Jira Cloud or Confluence Cloud servers and their internal databases, and then there is your cloud app. And so the only difference is that you just replace Java APIs with REST API calls, and you replace event processing with webhook processing. And so everything will be the same. But there's one major difference. One major difference is that if you look at some example API call. For example, in Jira Server, if I would ask project service get all projects, and typically in less than a millisecond, you will get all project data. If you would do the same thing on using REST API, search all projects, so typically it might take some 200 milliseconds or more. And if you can get all the project data in a single REST API call in a single batch, if you have many of them, so you need to make the next call, the next call, the next call. So this is the one major difference that you always need to remember, that REST API calls will be hundreds or 1,000 times slower than similar API calls were in your server case. And so the more correct picture would be that you should imagine that there is this huge thing, this internet, this cloud, and then on the one side of the cloud, there are some Atlassian servers running. On the other side of the cloud, you have your own cloud apps running, and then somewhere else there are users. And then when you are making some REST API calls, then somehow this request travels to these servers, and then hopefully it will travel, the response will travel back. But unfortunately, sometimes it will not travel back. And so you are wondering how it works altogether. So the other, and in our case, so nowadays we are making about 1 million daily REST API calls back to Atlassian. And so this is quite an important topic for us, so to make them somehow work. And so one thing what also should be considered, that in case of cloud apps, the technology stack might be quite different. And you should learn how your technology stack performs HTTP requests, what techniques to use to do profiling and optimization. So there might be a lot of different programming languages and different frameworks, like maybe use JavaScript and Node.js plus Connect Express framework. Maybe use Java and Spring Boot framework or something else. In our case, we use totally different technology stack. We use Ruby programming language, actually JRuby implementation of that, and we use Ruby on Rails framework. And there might be different hosting providers like AWS or Azure, or in our case, we use Google Cloud. And different external services, what you use, like databases, how you do monitoring and analytics. So in today's talk, therefore, I will focus not on particular technologies, but more on the general principles that I think that you can apply in every of your stack, but you should learn and understand how these things are happening in your programming languages and in your frameworks. So the first thing is that you, before trying to optimize something, you should understand what it is worth to optimize. We as humans, or we as programmers, are very bad at understanding what computers do fast and what they do slow. So typically, as I like to say, that all guesses about performance, what is causing bad performance, are wrong. So don't trust your gut feeling. And always start with instrumentation and profiling, meaning instrument where you want to understand what is happening. You instrument your these API calls where you know where they are happening and how many times you are doing that, how long they take place. And then you can build some profiling that over some time you can see how many times you are doing that, what are some average times, and what is the biggest impact, what is impacting what. And so the first recommendation regarding instrumentation, do not use directly frameworks HTTP request methods. So if you will go to some, for example, Atlassian Connect Express README, you will see code like this. So that's how you should do back the HTTP REST API requests back to Jira or Confluence. But when you're using these methods directly, so they don't provide by default any instrumentation and analytics to understand what you are doing and how long it was taken. In the same way, if you use Java and Spring Boot framework, it also, this is how it's written in the README, but I wouldn't recommend to use it directly. So instead, create your own wrapper methods where you pass to which site you would like to make which REST API request. And then in these wrapper methods, you can implement and, if necessary, change any instrumentation that you are doing or any additional logging in a common way. So if you then, as otherwise, if you would do it like before, so you are spread this code in a lot of different places and you need to then change it in a lot of different places, better encapsulate all the profiling in single wrapper methods for making REST API requests. And then, for example, if you are doing some REST API requests, like this example, you do some GET requests to particular Jira cloud site and doing search request, I would recommend that you extract from it more generic request type. For example, this is just GET project search request, or maybe you make it even more general, how to get all projects. And then and strip away any parameters from that. And also make this specific site as an optional category parameter by which you might want to analyze something. And then log these events, that how many times you did this project search and what was the response time of that. And then you can start to do profiling when you can get for each type of request that this request what was the average mean time, how long it took to receive the result, and what was the throughput, how many times per some time period you did these ones. And then if you multiply mean by throughput, you get the relative impact of that. And then you see what is on the top and what is worse to optimize. And it's not worse to calculate just some mean times of generic REST API, all request types, but better do them by different types. OK, so now when you have understood what you want to optimize and what you want to work on, so let's go back to the how HTTP requests are made and how REST API calls are executed. So let's look at HTTP request waterfall in the waterfall timeline. So in this case, waterfall is quite OK, so you don't need to switch to Agile right away. So let's stick with waterfall. So when you do the request, so the first thing is that your client machine will do the DNS lookup, which is typically quite fast and will be cached in your server. But then TCP connection is established, which will take some time. Then probably even longer, SSL or nowadays TLS connection will be negotiated and established. This will take some time. And only after that, so you can send the actual HTTP request. After that, you're waiting until it will be processed and will get some response, and you will receive results. And if you look at the timeline, then typically this first part typically might take some 100 to 150 milliseconds. So if you make all these individual requests in a standard way, so you are wasting about this amount of time just to establish the connection. And then the rest, there might be some, typically at least additional 100 milliseconds, and typically until 60 seconds if you made some very complex requests, then the backend, some web server will kill the connection and you'll get the error. But yeah, it takes a lot of time, establishing this connection. And if you want to check it out on your application server, you can, for example, use curl with the trace time option to see how long time will it take. So therefore, recommended approach is to use HTTP persistent connections and connection pools. So which means that instead of doing it every time, so you establish connection and then you make the request. In the previous HTTP versions, you needed to pass the specific header connection keep alive. So now, therefore, these are called either persistent or keep alive connections. Or in nowadays, you just don't close the connection, and you can continue to send the next REST API request over the same TCP connection, again, the next one, and so on. Therefore, it's good to maintain and keep these open connections over which you are making these connections. And you should consider these REST API calls similar how you use database. You have a database connection pool over which you are checking out connection, making requests, and then getting results back. So in the same way, you should use these persistent connection pools. And here are some links how you can enable that in Node.js or Connect Express or in Java. In our case, we are using JRuby, and we are using beneath that as well Apache HTTP client with specific adapters. So please investigate that, and you will save at least 100 or 150 milliseconds per each call. The other thing is, if you have an application server doing a lot of communication, a lot of different servers, you will have a lot of these open connections and a lot of these connection pools, because for each Jira site or Confluence site, you will need to maintain separate open connections. So you can monitor just with some Unix netstat command, or even better, if your hosting provider provides possibility to monitor how many TCP connections are active and in which states. It's good to monitor that, because so this each TCP connection also use file handle on your operating system, and by default, quite often it's some standard limits are some 4,000. In our cases, we are increasing that to some 10,000 or even more, because otherwise you might start to get strange errors that your establishing of TCP connections are failing. So now, so as we have seen that REST API calls are much, much, much slower. So they take a lot of time to establish. So of course, the first guiding principle is just make less requests. So that's always the guiding principle. So how we can make less requests to get the same results. And so what are different strategies how to do that? So well, at first, take a look at context parameters that Atlassian can provide to you. In your app descriptors, when you provide URLs, you can specify some additional context parameters that you want to receive already in the initial call to your applications, like project IDs, issue keys, but that's quite clear. So sometimes what we didn't discover ourselves initially and are working right now, that you can use also conditions as context parameters. Instead of just limiting whether someone can request this to you or not, you can get these conditions as parameters. So you, in these examples, I got that as a parameter, whether I'm in admin mode or do I have browse projects permissions. I don't need to ask that back to the product. And there are some links where you can learn about these different conditional parameters. Then, so the next recommendation is that you probably know is that when you're doing REST API requests, you can expand some additional fields that you would like to receive. Like when you are doing issue search or individual issue requests, you can expand changelog. Or for user, you can expand groups. Or for Confluence, there is you can, in quite detailed way, expand some history, versions, etc. So please explore that. As always, if you can expand and get in a single request results back, it's much better than making 2 or more requests for that. Also, limit what data you request, as it will both reduce the amount of data that should be sent back to you, as well it will minimize the amount of time to prepare the data on the product side. For example, in Jira case, when you do some issue search, you can specify individually which fields to receive. And by default, if you don't specify, it will return all fields. So better never do that. Always specify exactly the list of individual fields which you will be using. And the other thing, so in the issue, you can also have, in addition to fields, there's this new thing, entity properties for issues. You can list which properties you can request. So there's one thing that, for some reason, in Jira, you can list any number of fields that you would like to receive. For issue properties, you can just list up to 5 properties. So what to do if you need to get all of, or more than 5 properties? Then initial thought would be, well, I don't have any other option, so then I need to request individually each issue and ask for all properties. So this will be very bad in case of a large number of issues. Please try to avoid making individual requests for individual issues, as then it will not scale for larger instances. So the alternative implementation for that would be that you can make, again, in batches. You can search for these issues in one batch and specify a list of first 5 properties, then make the second request where you list all the issues for which you want to have the same properties, and list the next batch of properties that you want to get. So always think creatively how you can make less REST API requests. So that's the main guiding principle. And then, of course, cache frequent request results. So to make less of them. So canonical example would be for if you do user impersonation, and then when you do get the auth token for that, so then it already you get the amount of when it will expire. And so this request takes about, in our case, about 400, 450 milliseconds. So definitely it's worth to cache this information and reuse it and request again. So you need to evaluate which other data maybe are not so important to have the very latest version of the data, so request it later. So one performance improvement use case from our what we did this summer, that we had in eazyBI case, you are preparing different reports and dashboards, and then you can publish them back on as dashboard items or Confluence macros. This initial load time of iframes was not quite good, so users were seeing spinners for quite a long time because we needed to do authorization. We needed to get, understand for this user, get all the user groups and understand whether this user is admin or not, because the access rights are defined also either for individual users or for user groups or for admins. And initial implementation was that we always requested when we show the iframe, we were requesting back, please get me this user information, expand groups. Took about 300 milliseconds, then make impersonated request to get my permission administer, so to understand whether this user is administrator or not. So it could take, without cached access token, could take a second just to get this additional information. And so what we did there, so we learned that actually to understand whether this user is admin or not, we can add everywhere this as condition parameter, and we will get right away to know it, whether this user is admin or not. And also for user groups, so it's probably not so important to have always the latest data. So let's cache this for 5 minutes, and that would be fine. And as a result, we made 4 times less calls and improved response time by 500 milliseconds in average. And then, of course, you need to monitor that. And so there's some example that we monitored that by midnight on that day when we deployed that. So we significantly dropped the dashboard item load time, and the throughput for these particular requests got down dramatically. And so it was a very nice improvement. So the next thing is, as you know, that for large resources, you need to do pagination to get all the data. And so here are some ways how to do efficient and correct pagination. So let's start with a typical example. If we are doing issue search, then as you know that in cloud, you can get up to 100 results in a single page. And how you would do that, you start at offset 0, 100 results, process it, make the next request, next 100 results, process it, next one. So it will take quite a long time as in cloud, so there are already customers with million issues. So this will take quite a long time. And so our strategy for that is that we do parallel pagination. So we do the first request, and so just to check that still the page size is 100, so to understand what page size we could do. And then in a thread pool, we request next 3 pages in parallel. When the first request finishes, we do the next request for the next page. Again, the next request for the next page, next request for the next page. In this way, we significantly reduce the total time to paginate through large number of requests. But of course, in this case, you need to experiment and find out the optimal size. So if you will start to make too many requests, you might create a denial of service attack on that Jira Cloud side, and better don't do that, or you might start hitting rate limitations. So currently, we use 3. For issue search, for example, we use this parallelism of 3. But experiment and find what's the best for you. But also, when doing these paginations, so one thing that you also need to remember that these data that you are querying might change during the pagination, and there might be a lot of interesting edge cases. Let's have a look at a simple example. If we would search for all issues in a single project and update by updated date in a descending order, and let's assume that we have just 9 issues, and we'll split in pages by 3 issues. And initially, so these pages would be in the following order. But then let's assume that during the pagination, 1 issue was updated. So now the order is the following. And maybe at this point, the last issue, number 9, was deleted. So now the pages are the following. And so it could be possible that when you do pagination, you got at first this page, then that page, and then this page. And you can see you got issue number 7 twice, but you didn't get issue number 3. So you need to think that there might be different changes, and so process handle cases when you get the same item twice, or if you don't get something before deleting, for example, from your database, make explicit callback and check whether this issue is still present there or not. And then when you're doing this pagination, also remember that not all data are returned. Like, for example, when only first 20 worklog items per issue are returned. And so just to make it more confusing, last 20 changelog items are returned. So if you want to get all worklogs or all change logs, you need to make then specific additional queries. But in our case, we see that typically it's not such a bad, so typically the small minority of issues have more than that, and then we are making these additional calls, and it doesn't slow down significantly. Just remember that you need to check that you have received all additional data that you need. Error handling. So as you know that not all API requests will be successful. And requests might fail for many different reasons. And so here's some summary of different error codes that you might experience. So that's from our experience that you might get error code 400. So that we have seen that, which means just bad request. That is returned by auth Atlassian IO when you are requesting auth tokens for example, inactive users. You might get unauthorized 401 response, typically when a JWT token is invalid for some reason. You might get 403 errors, which means that forbidden. Then it's either your application is not anymore active, or impersonated user is not active, or does not have access to that resource. But sometimes it also might mean different things, as I have discussed with some other vendors. 404, which means not found. And then what you will get more often in the future is 429, too many requests, that you are exceeding request limits, which currently are not quite documented, so you don't know what's the good rate to make these requests. And then there are these 500 errors, which famous just 500 internal server error, which typically would mean that this is a bug in an Atlassian product or too high load, or 403. Then typically it's maybe there's some maintenance break or some front-end load balancer cut the requests, and 404 gateway timeout, so that we have seen more often previously when we are exceeding, the backend was exceeding 60 seconds timeout. And so you need to, well, not to fail everything after such first thing, so it's better to implement some retry strategy, but retry based on the error that you receive. So the correct recommendation would be that on these 400 errors until 404, you should not retry because response will not change. So unfortunately, that's not always the case. So sometimes Jira returns 403 error when there's some problems with database connection pool running out. So probably you should retry 403 errors as well. And so these other errors, so it's better to retry them several times, but the recommendation would be to use exponential back-off. So what it means that, so if you would do the retries right away, so it failed, you do it right away, again. If the server was overloaded, you probably are again causing, starting to do denial of service attack on them. And so it probably will not recover so fast. So it's better wait some time for it to recover. But so what time to wait? And so one recommended strategy is to do a retry and increase this retry time. So this is some simplified sample code how we do that. So at first we check retry after header, which probably will be implemented in the future. So that's the standard way for the services to return that please retry this request after such number of seconds. Currently, unfortunately, not returned by Atlassian, but probably will be returned previously. And so our current strategy is that, okay, for each request, we we by default retry them 5 times. Initially, we set the sleep seconds, wait seconds to 5, and then we at first retry after 5 seconds, then we retry after 10 seconds, then after 20 seconds. So each wait time is twice as long. And we even add some randomization, so not to retry some same time of seconds exactly in the same sequence. And that might help you to avoid different to get past some accidental errors, what you get. So the other strategy, when we do pagination, and when you get some 500 error, then, for example, you made some search request and for 100 issues, and you got error 500. And quite often, it might mean that there's some bug in the Atlassian product. They failed to render maybe one field in one issue. This caused some null pointer exception, for example. And instead of failing the full page, what we do, or the other probable cause is that it was too high load. And so what we would do that we split this page into 2 pages. So we let's try the first 50 and the next 50 separately. And probably the one will go through successfully. And then what will fail, we again split into smaller batches until we get batch size 1, which we don't retry. But using this strategy, you might maybe then miss just one issue, but you load other issues. OK, so let's at the end talk about some alternative approaches that you can use. And one is webhooks. And how so to make less REST API requests, instead of checking everything what has been changed to get the new data, you can listen and process webhooks and identify what data has been changed. And sometimes you might want to do some processing right away on some webhooks, and if you're doing some automation, some workflow processing. But in our case, as we're mostly doing data synchronization, for us it's OK to not to have the very latest fresh data and just to do these updates after some time period. And how we do that we process these webhooks, like issue created, updated, deleted, but then we store it in our Redis cache and just the issue keys. And just the set of unique issue keys, what has changed. And then periodically, we just take, during some time frame, okay, only those issues has been changed, and we can then just get the full details for these issue keys and process and update our information about that. Regarding webhooks, please remember that some webhooks might not be delivered. And so therefore, it's probably in addition, and how we are doing that in addition, better check whatever else has changed during this last time period, because maybe there was some other changes that you didn't get. But that's one approach using webhooks, how you can identify and minimize number of REST API requests just to request those data which has been changed. Another alternative approach is to use the new Jira Expressions API. Anyone has used Jira Expressions API? Some? Yeah, so then please, everyone else, have a look on that. So you can, for example, for issue searching, you can implement this as an alternative to issue search. For example, in our case, quite often we are scanning all issues to identify whether something has been changed, and we ask just created and updated fields and do the pagination through all results. And then we do these parallel requests to go through all of them. Based on our experience, even requesting for 100 issues just created and updated fields, it might take from half a second to 4-second response times. And that we have identified that the larger the customer instances, even requesting small amount of data might take quite a lot of time. And if you need to do that, so basically these queries are translated to SQL queries in Postgres database, select these fields, group, and offset and limit in SQL, and each one will result in new SQL queries and doing full scans there. There's the alternative to use Jira expressions. So there's the API where you can post to expressions API, and you can specify the same JQL, what to return, and you can provide JavaScript-like expression, which will, for example, in this case, return just issue key and issue created and updated fields. But the main difference is that here you can specify much larger max results parameter. You can, at least currently, do the pagination by 1,000 issues. And we experimented with that, so we could reduce about 5 times the total time to paginate through a large number of issues. And finally, so in future, so some of you probably were here at the GraphQL talk, and if not, then watch it later. That in future, Atlassian is promising GraphQL, which might solve some of the problems, but I think that a lot of things that I was discussing today will apply to GraphQL as well, and yeah, you will need to apply this as well. If I go to the summary of my talk, so I spoke about that you should learn how your technology stack performs HTTP requests. You should do instrumentation and profiling before starting any optimization work, understand what it is worth to optimize, and later analyze if you have improved something. And then practical examples, practical recommendations: use persistent HTTP connection pools, make less requests, cache frequent request results, do efficient and correct pagination, handle errors correctly and according to your application needs, and explore alternatives. So thank you. That was what I wanted to share with you today, and I have some couple minutes for questions.